Hello and welcome back to Little More Learning. Today we are starting with another data analysis programming language, that is R. So we will start this with an overview of R. So R is a powerful open source programming language specifically designed for statistical computing and data analysis. And it was developed by Ross and Robert in 1900s. So the key features of R include, firstly, statistical focus. So R provides a vast library of built-in statistical functions. Then, visualization power. R excels in creating high-quality graphs and plots. And thousands of community developed packages extend its functionality, thus adding extensibility as its feature. Lastly, it is completely free and community driven, that is open source. All these features enables the benefits of R in data analysis. Now, comparing R with the other tools such as Python, Excel and SAS. So, R is having a moderate ease of use in compared to Python, Excel and SAS. And statistically, it is very excellent to work with, as well as in data visualization. It works really good. Next, it is free of cost, whereas Python is also an open source language, but Excel and SAS comes with paid license and subscriptions. Lastly, for big data handling, it works good with it. Then we have real-world applications of R. R has been widely adopted in industries such as finance, healthcare, e-commerce, and academia. And their common applications in finance include risk assessment, stock market prediction, and portfolio analysis. In healthcare, analyzing patient data, drug trials, and disease predictions are its applications. Whereas when it comes to e-commerce, recommendation systems, customer segmentation, and sales forecasting are applications of R. Lastly, in academia, statistical research, publication quality, visualizations, and teaching are part of R's application. Before we move on to basic syntax for R, we should learn how to set up R and RStudio. So we can install R using CRAN, Comprehensive R Archive Network. And we can choose the operating system we would work upon, like Windows, Mac OS, or Linux, and download the appropriate version of R for your system. Follow the basic instructions of setting up a new language. And then it comes to RStudio. So what is RStudio? RStudio is an integrated development environment, or IDE, that makes coding in R more user-friendly. It provides a graphical interface to interact with R more effectively. You can download it using the RStudio website and download the free version for your operating system and install it by running the installer file and following the setup process. Let's move on to basic syntax and operations in R. The first thing that we're going to look at is variables. So a variable is used to store data that can be reused later. The first task is to assigning values to variables. We can use the operator to assign values to the variables, or we can use this equal operator. But this one is more preferred in R. Now, the basic syntax, what you can use using this operator, you assign the value 10 to x, and using equal to operator, y to 5. And finally, z has the value of x and y addition. So z will have the value 50, and this statement will print the value, that is 50. So the rules for naming the variables is like any other programming language. Like, it must begin with a letter. It can include letters, numbers, or underscore, and it cannot contain any space or special character. For example, is a valid variable, and this is also a valid variable. Next come up if you want to check the type of variable you have declared. So for that, you will be use class function, and this returns the data type of X. That is, for example, if taking the previous code, it will be numeric. Then we have data types in R. There are several basic data types that we can use in R. Firstly is numeric data type that has real numbers that are integers and floats. For example, 1, 2.5, minus 3.8 are all numeric values. Then we have integers that are whole numbers and always have L as suffix, like 3L, 7L. These are integer. Then we have character data type that has text or string, and it is always written in double quotes. So hello is a character data type. Or we can have like this, or we can have just a single character as string words. Lastly, we have logical data types that are Boolean values, and everyone knows that they are either true or false. Next, moving on to basic arithmetic operations that we can perform in R. Firstly, that is addition. Let's take two variables and assign them their respective values. Now, when we have to perform addition on them, we can simply use the print statement, a plus b. For subtraction, it can be a minus b. Multiplication, it follows a star b. Then for division, the division operator is used. For modulus, we use the percentage operator twice. And lastly, for exponentiation, we use this operator. So when these operations are performed on these variables, their output will come out to be accordingly. For a plus b, it will be 30, a minus b, it will be minus 10, then 200, and so on. It will continue. And the order of operations, like if we have multiple operations, suppose there is a variable named result and we are storing the value into it, something like this. So there are multiple operators being used here. For this, R use PEMDAS or BODMAS. You all might be familiar with what these two terms means. Then we have logical operations. The first one is to check the value, that is equal to. Next one is not equal to. These are for less than or greater than. This is for less than equal to, greater than equal to. This is logical and this is logical OR operator. Next are comments in R. We can declare comments using the hash symbol. So this is comment number 1 and this is comment number 2. Now there are some built-in functions in R that help us to work with data with much ease. Like we have in mathematical functions, we have square root function to calculate the square root, that will be 5 for 25. Then ABS for absolute value. Here it will be 10 only. It should be minus 10. Then log for natural logarithmic and exp for exponential function. Then we have statistical functions. Suppose we have a variable x that has the following values, and we can calculate mean, median, sum, and length. Length calculates how many elements are there in the variable, so it would be 5 here. Then we have string functions. Suppose we have a string here. Let's take a variable text and enter this string into it as data analytics. nchar function is used to calculate length of the string, and here it would be 14. toLower just changes the case of the string. In that case, all the letters in the string will be converted into lowercase, and lastly toOpper, it converts them back into uppercase. So all the elements of the string will be converted into uppercase. Now, all of these were built-in functions. How can you create your own function? Now, this is a function to calculate the square of a number. We start by writing the name of the function, and this symbolizes that we will be passing on to a parameter to this function, and then we are using a variable named string and passing on the value of x squared to it, and then returning the result. Now in the print statement, we are calling our function by its name and passing on this parameter as 4. So the output of this will be 16, as it will work for 4 to the power 2. Last topic for this will be data structures in R. So R provides a rich set of data structures to handle and manipulate data. Understanding these is crucial for data analysis. So right now we will just understand the names of the data structures. In the next one, we will have a deep dive into them, like how they work, how we can use them in the code. That will be continued in the next video. So data structures in R include vectors, matrices, lists, data frame, and factors. What are these? How we work with them? We will continue on in the next video. Till then, keep practicing. See you in the next video and happy learning.